deployment. Probably want to roll that back. In other words, 10 milliseconds latency might be out of bounds. And probably the most important metric out of what we call the golden metrics is error rate. You can build a very good canary-based early warning system on error rate alone. How many errors does your application get, right? If it's HTTP, how many non-200 response codes are getting flowing through that? Very easy to collect, very easy to measure, and if you get one, probably roll it back, right? Or one that looks suspicious, probably roll it back. I have this quote that I like from someone on my team. Modern applications are sufficiently complicated that they need to be formed by the instruments. You think about an aircraft. A lot of people don't realize this, but aircraft, they literally can push a button and the aircraft will taxi down the runway, take off, fly to its destination, avoid weather, land, go to the next gate with barely any intervention from the pilot, right? The pilots are mostly there for safety and in case anything really bad happens on the flight, which is good, right? Because the computer systems are doing a good job. We haven't even applied machine learning yet to some of these systems. For Christ's sake. For Christ's sake, I know. Where planes are going to be, God forbid. Well, I actually think that the same is true here for application design, right? Like we need to get to a place where applications are flown by the instruments. Because what that means is that people will then be freed up to write more applications. And that's ultimately what we want, is more business value being delivered through more applications. So, my goal at Microsoft is, it's funny, I sometimes look and I'm like, wow, like how did I get here? Like how did I get to this position where I have the ability to impact developers at a pretty big scale. And so I really want to do something fun and great and impactful for developers and for operations folks around the world. So I think about this a lot, and some of the things I want to do here, I want to promote white box abstractions over black box. The same principles that we used in Deis workflow. Like don't hide things from developers. Let's make it easier for them to sort of swim with the stream on tooling. Let's make it simpler for them to get onboarded. But let's not hide it behind some abstraction that we just know is going to break, and people are going to get upset, and then want to know what's happening under the hood. I don't think we need to do that. I think we can tool around it. As I talked about, I want to automate canary deployments. This is something that I think is going to greatly accelerate the industry, and we're doing a lot of work in this area. I can't talk about all of it, but we're doing a lot of work, and you'll start to see some of this landing soon. Another thing is delivering contextual dashboards. So I've learned at Microsoft, I'm a CLI person. I like command line. Right? I like my black screens. I like the dark room. It's funny, in the offices, so I have an office, a Deis office, Deis office. It used to be the Deis office, now the Microsoft office in Colorado, where a lot of the people who work on AKS actually sit. And it's funny, most of the people there also like command line and sort of that sort of thing. So much that they all have dark screens and the lights are always off in the office. So when I have customers come visit or anyone come visit, I'm like, guys, engineers, come on, turn on the lights. And they're like, Gabe, it's bright, it hurts. But not everyone is like that, right? A lot of people want graphical experiences. They want GUIs, they want telemetry shown in portals, and this is a big thing that is important to empowering more people to do more with this technology. And I also want to make it safe to develop in production. And I want to be clear, develop new code in production. Ultimately, I think this is where as an industry we need to go. I think the idea of development and staging in production environments will always exist, right? It's always going to exist. But I think if we can make it safer to develop in production, I think a lot of people are going to be better served with that. And so I want to show you a little something, and as kind of an example here. So let me see if I can pull this app up. Okay, so this is Smart Hotel 360. This is a hotel website, right? And let me show you what it looks like. Sorry, I gotta move around my coop configs. Anyone do this, by the way? Anyone do what I'm about to do? Move their coop configs around by hand. right. Okay, so clear. Okay, this is my app. I've got a booking service, configuration service, discount service, the hotel's API service, the notification service, profiles, the public web, a reviews system, a suggestions system, a task backend, and then 2 data stores, one for the SQL and one for the task, plus a bunch of other data stores that are connected to this backend application. This is what a microservice, real microservices actually. Okay? And interestingly, when you query this application, the path that I'll show you is going to go through the public website, and then we're going to query this hotel's API. But all queries could also flow through other directions. So let me set the stage. I am Gabe. It is my first day working at Smart Hotel 360. My boss wants me to fix a bug in production on my first day. So how am I going to go do that? Well, first let me show you how the site works. So this is the site. So if I go in and I type in New York, you can see that, I spell it correctly, you can see that I have New York that comes up. I can book my times, I can find a room, and everything works great, right? The bug is that if I type in Seattle, nothing comes up. And this is a problem because we have a conference coming up in Seattle, Microsoft Build conference, by the way, real conference in Seattle. In May, we're going to launch a bunch of new stuff. And the data is not showing a response. And I want to point out, this isn't a logic bug. This is actually very akin to the type of bugs that you'll run into in production. This is a mix of code and data. How do you model, like if I ran this on my laptop, I might not even be able to reproduce this bug, right? Really hard to reproduce data bugs. So, how am I going to fix this? Well, the first thing I'm going to do is use something called an Azure Dev Space. So the way I use Azure Dev Spaces is through the CLI, azds space select, and the name of the space is going to be Gabe. And what this is going to do is this is going to configure a dev space for me. This is my space, where I can basically play around with the system. I can debug containers. I can sort of do what I need to do from an inner loop perspective while I'm developing software. Now, okay, I've selected my space. So let me go into VS Code here for a minute. And let me take a look. So this is the hotel's application, the hotel service, smarthotel.services.hotels. Actually, I can't really read that. What you'll see here, whoops, I didn't reset. Okay. Yeah, sure. Thanks. Bending over my back. Sorry. It's okay. Okay, so what I can do here is I'm going to look at the city's controller of this application. And what I'd like to do is I'd like to hit F5 to run this code. And what you can see is what we're going to do is we're going to synchronize the files that are running inside of this container. And we're going to synchronize this and compile some code. And then it's going to run this code and set a breakpoint on this code. Now, if you've ever used .NET or developed on Visual Studio, you'll know that this is normal, right? What's not normal is how this is actually working. If you do a get all and namespace Gabe, what you're going to see is there's actually a pod running in Kubernetes. Again, integration test remotely, right? We're running this in the cluster, and the breakpoint is actually set on this pod in the Kubernetes cluster. Okay, great. Now, how do I actually access this? Well, what I can do is I can actually put gabe.s for Gabe space as a prefix onto this URL. If I hit enter, everything looks the same. And in fact, everything is the same. The only difference is when I call the hotels API with this prefix, it's going to route to my hotels container. So if I go in and type in Seattle, oh, sorry. I forgot the part where I set the breakpoint. If I type in Seattle, what you're seeing is pop a breakpoint. So first, I want everyone to just like stop and be like, okay, wow, we got breakpoints back, right? Who remembers like breakpoints, right? Like seriously, like we started doing containers and then it was like all software debugging like left, right? And we just don't do it anymore, right? So annoying. By the way, most of the time, I've done a lot of large work on large systems. If I can't see a call stack and locals, I cannot fix anything. So I don't know how you all do it with your print line debugging, but call me an old timer. But what I get to do here is I get to look at this query and see the results. And I can see, oh wow, this return of the cities is actually returning an empty list. So the front end is doing what the front end is supposed to do because it got a null list. So we'll release the breakpoint. And then I'll dig into this code, and what I can see here is, this is the get on cities, and this, what is this, get default cities. You can see, oh God, look at that. It's a hard-coded list of cities. Who would have thought someone would have hard-coded a list of cities, right? So, okay, fine. So what we'll do is we'll close that. Sorry.
First you do a blame.
Yes, first you review the blame. You send an email to the manager, and then you go back and fix it. So what I'll do here is I'll just do what I should have done in the first place and actually query the database normally. And I can save this. And then what I can do here is I can go ahead and debug this again. And what you're going to notice is that, I'm synchronizing the files and I'm recompiling the program, but I'm not rebuilding the container image. I'm not, this is actually hot loading into the container runtime in the Kubernetes environment. And so what I can do now is I can go back to this and, I don't even really need to refresh the page, but I can type in Seattle again, or SCA. Did I actually get the debugger? There it is. Okay. And you can see that my cities now returns a list. Okay. So this is actually working. So I fixed the bug. That's great, right? I've impressed, I can now commit this change. I can now merge this change into version control, into master branch, and that'll kick off my outer loop process, which will roll this out to production like we talked about before. So again, I fixed this in my branch. But if I remove this prefix and I go back here, you'll notice that in the main space, the default space, this is still broken, right? So this is an example of how we're using something called Azure Dev Spaces to make the process of debugging distributed applications easier through something that we call connected development. Cool. Any questions on connected development? No? All right. Poor Manuel already saw that demo. So for Manuel, I am actually going to show you guys something else that is actually not at all related to this session. Who here is familiar with the concept of serverless containers? You don't count. Okay. Who here has heard of Azure Container Instances or Fargate? Okay, a few of you. Okay. Microsoft came out with this thing called, here I'll pull up the website so you can look at our glorious marketing. This, Azure Container Instances. So Azure Container Instances is serverless containers. We run containers directly on the Azure Compute Fabric with no virtual machines to manage it all. It's per second build. Every container execution is hypervisor isolated. It actually uses the Kubernetes pod spec, which may give you a hint as to what's running under the hood. So these serverless container instances we came out with a while ago. I think it was June of 2017. And about 6 months later, Amazon came out with Fargate. They were sort of big on the idea as well. But one of the things I want to mention is when Brendan and I launched this, we launched a project that was later renamed to the Virtual Kubelet. The Virtual Kubelet is a way for you to bridge Kubernetes with these serverless container runtimes like ACI. And so let me show you how this works. So if I take a look at my different cluster, you can see that, you can see that I have 2 agent nodes. I have 2 agent nodes And I have this thing called the virtual kubelet. The virtual kubelet shows up as a node. It's not really a node. It's kind of like a node, but it's more like an API bridge. But it pretends to Kubernetes like it's a node with unlimited capacity. So you can place as much work as you want and it will never get full on the node. Truth be told, it can actually get full, but we don't typically see that often in cloud. All right, so if let me show you a little bit about what the workloads are that are running on this cluster. We have this thing called Tensor stuff, which is a web front end, and then we have TensorFlow workers. Let me pull up the UI for this. So this is the app. It is a TensorFlow-based image classifier, right? Very simple, okay? Looks at a picture, determines what's in the picture, okay? We have one worker running right now, and that worker is running on VMs in my Kubernetes cluster. But let's assume that my cluster is full. Yeah, you'll see it's not right all the time. The cognitive services team at Microsoft would be embarrassed. So anyway, so I want to scale this up, all right? And when I'm scaling this up, you can envision lots of different scenarios for reasons why you might need to scale. So first I'll go into the right directory, VK, TensorFlow, and I will do a helm bounce of this. And let's add 100 new workers to this cluster. Okay. And I'll set up a watch so you can kind of see how this flows. But if you take a look at if you take a look at this watch, what you're going to see is the pods running through the normal Kubernetes state machine. They're going to get scheduled, they're going to go into creating, they're going to go into awaiting status, they're going to go into running, and everything's going to work normally. But the only difference here is that they're not actually getting scheduled to a Kubernetes node, they're getting scheduled to this virtual kubelet, which is then running the pods on a separate service called ACI. All the networking and everything all works seamlessly. Now, as these pods are starting to come into the picture, I want you to think about how long it would take for these pods to come into service if we were bound by VM-based scaling. If we were bound by VM-based scaling, we have to wait for the VM to provision. We have to wait for the VM to boot into